Now the addition formula. For tan function. That is, we have to find tan alpha plus beta and tan alpha minus beta. So the first one is, if alpha beta and alpha plus beta belongs to domain of tan function, that is r minus odd multiple of pi by 2, then tan alpha plus beta is equal to tan alpha plus tan beta over 1 minus tan alpha into tan beta. So we have to derive this formula. So how can we derive this? Obvious, with the help of sine and cosine formula. As tan alpha plus beta is equal to sine alpha plus beta over cos alpha plus beta. So by opening the formula of sine a plus b, that is alpha plus beta, it becomes sine alpha cos beta plus cos alpha sine beta over cos alpha cos beta minus sine alpha sine beta. As cos alpha and cos beta is not equal to 0 for r minus odd multiple of pi by 2, as at pi by 2 cos is 0. Therefore, dividing numerator and denominator by cos alpha cos beta, we get tan alpha plus beta is equal to sin alpha over cos alpha plus sin beta over cos beta over 1 minus sin alpha sin beta over cos alpha cos beta. So we get, that is tan alpha plus tan beta over 1 minus tan alpha into tan beta. That is our required result. So in the same manner, we have to find out tan alpha plus beta, alpha minus beta. So by just changing the sign alpha minus beta, we get sin alpha minus beta over sin cos alpha minus beta, as tan is sin over cos. So using the sign subtraction formula, that is sin alpha cos beta minus cos alpha sin beta over cos alpha minus beta, that is cos alpha cos beta plus sin alpha sin beta. So as we said in the previous topic, that is cos alpha and cos beta are not equal to 0 for the given domain. Therefore, dividing by cos alpha cos beta numerator and denominator, then we will get sin alpha over cos alpha minus sin beta over cos beta over 1 plus sin alpha sin beta over cos alpha cos beta. So we get tan alpha minus tan beta over 1 plus tan alpha into tan beta. So from the above formula we get that If we have tan alpha plus beta, that is tan alpha plus tan beta over 1 minus tan alpha tan beta. And we have to form the formula of tan alpha minus beta, that is tan alpha minus tan beta over 1 plus, that is the opposite sign of the given formula, that is 1 plus tan alpha into tan beta. So this was the addition formula for the tan function on the given domain. Now addition formula. For chord function. As we done in the case of tan function, we will do the to create chord addition formula in the same manner. So the first part is if alpha beta and alpha plus beta belongs to domain of chord function, that is r minus k pi, for k belong to z, that is a domain of chord function. Then chord of alpha plus beta is equal to chord alpha chord beta minus 1 over cos beta plus chord beta plus chord alpha. So we have to derive this formula. So as that in the same manner, that is the first step, that is chord alpha plus beta. It can be written as ratio of cos alpha plus beta over sin alpha plus beta. Then use addition formula of cos and sin, that is cos alpha cos beta minus sin alpha sin beta over sin alpha plus beta, that is sin alpha cos beta plus cos alpha sin beta. So we get as cos alpha and cos beta is not equal to 0 for all alpha beta belongs to domain of chord function. Therefore, dividing numerator and denominator by sin alpha and sin beta. So we have to check here, rather sin alpha and sin beta is not equal to 0 for all alpha comma beta belongs to domain of chord function, as domain of chord function is r minus k pi. On the values of multiple of pi, sin is always 0. So at alpha beta belongs to r minus k of pi, so sin alpha and sin beta is not equal to 0. So we get chord of alpha plus beta is equal to, that is cos alpha cos beta, it becomes cos alpha cos beta over sin alpha sin beta minus 1 over, that is cos beta over sin beta plus cos alpha over sin alpha. So we will get chord of alpha plus beta is equal to chord alpha chord beta minus 1, that is chord beta plus chord alpha. So we get the formula. Similarly, the second part is find chord alpha minus beta for the given domain, that is chord alpha chord beta plus 1 over chord beta minus chord alpha. So the solution is, as we have chord alpha minus beta, that is cos alpha minus beta over sin alpha minus beta. So by using the subtraction formula, we get cos alpha cos beta plus sin alpha sin beta over sin alpha cos beta minus cos alpha sin beta. So as sin alpha and sin beta is not equal to 0 for all alpha beta belongs to domain of cot. Therefore, dividing by sin alpha into sin beta, we get, that is, cot alpha cot beta plus 1 over cos beta over sin beta, that is cot beta, and cos alpha over sin alpha is, that is cot alpha. So this is the required result or the addition formula of cot function. So by using these addition formula of cot and tan, we can derive some important result in next lecture. Now we are going to find some important result using additional formula of tan and cot function. So first of all, we are find the value of by using addition formula, that is tan pi by 12. That is, we can write it as tan 4 pi minus 3 pi over 12. That is tan pi over 3 minus pi over 4. So we get tan A minus B, that is tan A minus tan B over 1 plus tan A into tan B. So we get under root 3 tan pi by 3, tan pi by 4 is 1, 1 plus 1 into under root 3. Now we will rationalize it. So multiply and divide by under root 3 minus 1 over under root 3 minus 1. So in the numerator we get under root 3 minus 1 whole square over a square, that is under root 3 square minus b square. So we get a minus b whole square is equal to a square plus b square minus 2ab over a square minus b square. That is 3 plus 1 minus 2 under root 3 over 2. So that is tan pi by 12 is equal to 4 minus under root 3 over 2. That is 2 is taken common out and we get 2 minus under root 3 over 2. That is 2 minus 3. So this is the value of tan pi by 12. Now we will find the value of cot pi by 12 in the similar manner by using cot addition or subtraction formula. So pi by 12 can be written as 4 pi minus 3 pi over 12. That is cot pi over 3 minus pi over 4. So again cot A minus B is cot A into cot B plus 1 over cot B minus cot A. So we get cot pi by 3 is 1 over under root 3 and cot pi by 4 is 1 plus 1 over 1 minus 1 over under root 3. So we get, on taking LCM, we get 1 plus under root 3 over under root 3 minus 1. So rationalizing the denominator, that is we are multiply and divide by under root 3 minus under root 3 plus 1. So in this we see In the numerator we get under root 3 plus 1 whole square, and in the denominator we will get a square minus b square, that is under root 3 square minus 1 square. That is cot pi by 12 is equal to under root 3 plus 1 whole square over under root 3 square minus 1 square. So a square plus b square plus 2ab over 3 minus 1. So we get 3 plus 1 plus 2 under root 3 over 2. So we get 4 plus 2 under root 3 over 2. Therefore we get 2 is common out, that is 2 plus under root 3 over 2. So we get 2 plus under root 3. Therefore value of cot pi by 12 is 2 plus under root 3. Now by using these two values we can also find out that is the value of tan 5 pi by 12. 5 pi by 12 can be written as pi minus 6 pi minus pi over 12. That is tan pi by 2 minus pi by 12. So we get tan pi by 2 minus theta is in first quadrant, and at pi by 2 its t ratio changes, so it becomes cot pi by 12. So what is the value of cot pi by 12? That is 2 plus under root 3. So by using this criteria we can find the value of cot 5 pi by 12. So it can be written as cot 6 pi minus pi over 12. That is cot pi by 2 minus pi by 12. So cot pi by 2 minus theta is tan theta. Therefore cot 5 pi by 12 is tan pi by 2 minus cot pi by 2 minus pi by 12 is tan pi by 12, that is tan theta. Tan pi by 12 is 2 minus under root 3. So similarly we can find so many values by using these values and using addition and subtraction formula of cot and tan.